MTP2 layer is mainly concerned with transmission of signaling unit from one endpoint to the another. It's basically concerned with reliable transmission of signaling units. And on the if you consider it uh, in comparison with OSI model, then MTP2 layer is totally in sync with the layer 2 of OSI model, which has the link layer functions. It is not concerned with routing, it is just concerned with the immediate endpoint. So even if the signaling unit is meant for some other unit, it will just take into account the immediate hop for the transmission. Now, one of the concepts that comes for MTP2 layer is signaling unit alignment. What this means is uh, MTP2 layer has to send packets, the unit of signaling information onto the wire. What it actually sends at MTP1 layer is just 101010, just the digital information. So somehow it has to be packetized. So there has to be a defined beginning and the defined end for the signaling unit. So this process for delimiting the signaling unit is called signaling unit alignment. So suppose it has to send the XXX information over the wire, then it will basically send the flag first and then send that information and then again send the flag later on, so that the signaling unit is packetized over the using these flags in between, before and after the signaling unit. This process is called signaling unit alignment, and the flag that is used for it has to be obviously agreed upon flag by both the units, by both the signaling entities, and that once it receives that flag, it will trigger uh, the actual reception of the packet. Now, another concept, another difficulty that comes with this is it may so happen that the flag appears in the actual data itself. So, if that is transmitted as it is over the wire, then the other entity will get the false alarm that the packet has ended, or some false alarm in actually receiving the packet. So, to avoid this, this logic of bit stuffing is used. Bit stuffing is basically somehow to avoid uh, appearance of the flag in the main packet. So in order to do that, typically the flag is 6 times consecutive 1 and 0 on both the sides. So it's basically 0 1 1 1 1 1 1 0. So that's the flag. Now this pattern should not appear in the in the main packet. So to avoid that, we use the concept of bit stuffing, and we encounter more than uh, whenever we encounter 5 consecutive ones in the data packet, we just insert a 0 after that. So this way the whole pattern breaks and never we find 6 consecutive ones. Similarly, on the receiving side, it takes care that whenever it receives 5 consecutive ones, it ignores the immediate 0. That way, that bit stuffing is removed and the actual packet is retrieved. For example, as you can see in this example, there are 8 bits 8xxxx. So when sending it on the wire, MTP2 layer will append and prepend the flags on both the sides for transmission. So the actual transmission on the wire will be 0 1 1 1 1 1 1 0, and the XX 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 XX, and then again the flag repeated. And with the bit stuffing, suppose that the actual data packet is 8 times 1, then obviously it can be mistaken for the flag. So uh, so the actual information is sent. First the flag is sent, that is 0 1 1 1 1 1 1 0, and then after 5 ones, one extra 0 is stuffed, and then the remaining bits are sent, and after that again the flag is sent. Similarly, on the receiving side, after receiving the 5 consecutive ones, it will ignore the 0 coming after that, and that way it will receive the exact number of bytes in the packet at the receiving end.